is Jonas Achobi, and today we shall be discussing on the topic rectangular coordinates. Sometimes we refer to it as the Cartesian coordinates. So we begin. So, making reference to this diagram on the left side of my note, let x prime x, and y prime y, this line, be two perpendicular lines that meet at point O. So point O here is the origin. Or of course, with this, it means that the values from 0 to x are positive values of x. The values from 0 to x prime are negative values of x. The values from 0 to y are positive values of y, and the values from 0 to y prime are negative values of y. So we say that any point P in this plane, so any point, say point P in the plane, is located a distance x and a distance y from y prime y and x prime x respectively. What are we saying here? We are saying that on this plane, to locate a point P, we must first locate the x distance of that point and also locate the y distance of the point, so that this point P is now point P, x, comma, y. So the point here, P, is x distance on the x-axis and y distance on the y-axis. So we now call this point P, x, comma, y. Now, the distance x, this x here, is called the x-coordinate or the abscissa of point P. The distance y is called the y-coordinate or the ordinate of the point P. The ordered pair xy, is called the rectangular coordinate of the point P. Now the point I want to emphasize here is this two words, ordered pair. What does it really mean? Now when we say that xy is an ordered pair, what it means is that x and y cannot be switched, in the sense that we cannot write x, y as y, comma, x. Ordered in the sense that their positions are fixed. For example, if I write a point, for example, -1 and 2, this point will be an ordered pair in the sense that -1 corresponds to the x distance and 2 corresponds to what? The y distance. In other words, I cannot write -1 and 2 as 2, -1. Are we together? Ordered pair. -1 belongs to the y-axis, to the x-axis rather, and 2 belongs to the y-axis. So with this, so P, x, y, this is what we now call the rectangular coordinate of the point P. So P is a point on this plane with x distance small x and y distance small y. Now let us look at the following. Let's assume we have 2 points, say point P, 2, 3, and another point Q with coordinates -3, -2, 3. Question is it possible to represent these points P and Q on a rectangular coordinates? The answer is yes. Let us attempt a sketch. So we can put up this sketch. Here is our origin. Here is our positive x-axis. Here is our negative x-axis. Here is our negative y-axis. While here is our positive what? Y-axis. So let us attempt to, so if this is 0, let's say here is 1, here is 2, say 3, say 4. This is negative 1, negative 2, negative 3. Negative 1, negative 2, negative 3. This is say 1, 2, 3, say 4. So how do we locate this point P on this rectangular plane? So the first one, point P, has two coordinates 2, 3, where 2 belongs to the x, is the x distance, and 3 is the y distance. So how do we get it done here? 2 is positive on a positive x-axis. So we call it, this is where 2 is. Are we there? And 3. This is where 3 is. So where do they meet? We trace it up. And we see that they meet at this point. So this is where point P 2, 3 lies on the plane. So also, how about point Q? Point Q has coordinates negative 2 and 3. So negative 2 on the x-axis. This is negative x-axis. So minus 2 is here. And 3, positive 3 on the y-axis is here. So we trace again to see where they meet. And we see that those 2 points meet here. So we call that point Q, negative 2, 3. Now this is how we can get the position of every point on a rectangular plane. So if you're given a point, say point R, with coordinates -7 and 8, you can get this position of this point R on this plane just the way we have done for P and for Q. Okay, let us discuss a concept called increment. Increments. Now, let us consider this figure below. Let us consider this figure. This is our rectangular plane. We have 2 points. Point P1 with coordinates x1 and y1. We have another point here, say point P2, coordinates x2 and y2. Now, if a particle moves from point P1 to point P2 on this plane, we would say that its coordinates, which are x1, y1, x2, y2, have changed by increments. Now, the particle was at P1 with coordinate x1, y1. It moved from P1 to P2, and our new coordinates are x2 and y2. So there's a change in the x coordinate, which we shall call change in x, delta x. And there's also a change in the y coordinate, which we shall denote as delta y. So the first part of it. So the change in the x coordinate is given as x2, the second x2, the x coordinate for the second point P2 minus x1. And the change in the y coordinate will be y2 minus y1. Let us take quick example, 2 quick examples to illustrate this example. We want to determine the increments of the first one is the point A with coordinates -2, -1, 2, to point B, coordinate 6, 7. So solution. Now the particle here has moved from point A with coordinate -1, 2 to the point B with coordinate 6, 7. So the change in the x is what? Now the next question is, what is our x1 and x2? Our x1 is the first x coordinate for the first point. So this is our x1, and our x2 is this. So change in x gives us x2 minus x1, which is equal to x2 is 6 minus x1 is -1. So that is minus 1. And that gives us 6 plus 1 equals to 7. A change in y will be y2 minus y1, which is equal to, so here, this is our y1, which is 2, and this is our y2, 7. So y2 is 7 minus y1 is 2. And this gives us what? 5. So we would say that the increment along the x coordinate or in the x coordinate is 7, and the increment in the y coordinate is 5. Okay. We now look at distance between 2 points, with known coordinates. Distance between 2 points with known coordinates. We shall sketch our rectangular plane once again. We have point P1 with coordinates x1, y1. We have another point here, P2, with coordinates x2, y2. Now the straight line from P1 to P2 represents the distance from P1 to P2. And I wish to call that distance D P1, P2. So D P1, P2 means the distance between point P1 and P2. It is this distance we are interested in getting. We want to know get a formula that will help us calculate the distance between point P1 and P2, and of course the distance between any 2 points on a plane. Now to do this, we shall construct the following. If we drop a straight line from P2 parallel to the y-axis and drop another straight line parallel to the x-axis, these two lines meet at a point which we shall call point P3. The next question is, what will be the coordinate of point P3? Let us figure it out. Now, you see that point P2 and point P3 share the same x distance here. So the x coordinate of point P3 will be the same as that of point P2, and that will be x2. Also, point P3 and point P1 share the same y coordinate. So the y coordinate of point P3 shall be what? y1. Since P2 and P3 are parallel to the y-axis, or to the y line or axis, we'll say okay that the distance between P2 and P3 is nothing but what? The absolute value of y2 minus y1, since they are parallel to the y-axis. So the distance between these 2 points, or the distance from point P2 to point P3, is y2 minus y1 in absolute values. And of course, also the distance from point P1 to point P3, which we'll call dP1, P3, is nothing but what? Absolute value of what? X2 minus X1. Since these 2 points, since this line is also parallel to the x-axis. Question is, distance from P2 to P3 is this. The distance from P1 to P3 is given as this. What then is the distance from P1 to P2? Now, if you observe, we can't call this distance y2 minus y1 because this line from P1 to P2 is not parallel to the y-axis. We also cannot call this distance x2 minus x1 because this line, once again, is not parallel to the x-axis. So we must derive a formula for this distance P1 and P2. Now, we observe that the triangle formed so far, P1, P2, P3, is a right angle triangle with a right angle formed at the point P3. Since the triangle is a right angle triangle, we can apply our Pythagoras rule. So, by Pythagoras rule, now what does this rule state? This rule states that in a right angle triangle, okay, the square of the hypotenuse is equal to the sum of the squares of the other two sides. In a triangle, the hypotenuse is dP1, P2. The hypotenuse is d of P1, P2. The other two sides are d P2, P3 and d P1, P3. Pythagoras rule says the square of the hypotenuse is equal to the sum of the squares of the other two sides. So this is equal to the distance from P2 to P3. Distance P2 to P3 is what? Y2 minus what? Y1. So we replace this with this. So this distance is Y2 minus Y1 all squared plus the distance between points P1 and P3. P1 and P3 is what? X2 minus X1. Again, all squared. So distance P1, P2 all squared is equal to this. But what we are looking for is the distance between points P1 and points P2, and not the square of the distance. So how then do we take the square out? We take square roots. Take square roots on both sides. We take square roots on both sides. So if we do that, we now have that the distance from point P1 to point P2 is equal to the square root of Y2 minus Y1 all squared plus X2 minus X1 all squared. The formula just derived is called the distance formula. Distance formula. So this is the distance formula between 2 points P1 and P2 whose coordinates are known. What are the coordinates of point P1 and P2? The coordinate of point P1 is x1, y1, and that of point P2 is x2 and y2. So moving forward, whenever you are given 2 points on a plane, and you're asked to find the distance or to calculate the distance between any of those 2 points, we use this formula, formula 1. Of course, if you look closely to the formula, you observe that y2 minus y1 is nothing but what? It's nothing but the change, the increment in the y-axis. in the y-axis rather, beg your pardon. And x2 minus x1 is nothing but the increment along the x-axis. So in our next class, we shall demonstrate how we use this formula to calculate distance or distance between any given 2 points on a plane. Thank you.